right, hello Math 10. We're going to be jumping right into our domain and ranges, except this time we're going to be looking at those continuous graphs, okay? So in the last lesson, we were looking at domain and range, but we were looking at ordered pairs, right? We're looking at specific points on a graph where they were discrete, so we can make a list. We knew exactly it would be this point, this point, this point. So these are the domain values, these are the range values, and they're very explicit, right? But when we're looking at a continuous graph, remember, a continuous graph is just a consistent line or curve, right? So something like this or like this is considered to be continuous because there isn't any specific points that you can see. It's every single point in between. The thing with continuous graphs and continuous relations is that we have to consider what types of numbers we're dealing with, right? You know, we have here, I've got it marked off on this one, for example, we're going to go to 2 here, right? You know, or -2. And in the x-axis, we're going this way, right? But because they're continuous, we also get every single possible number in between, right? So we get 2, 2.5, 2.25, 2.225, 2.22225. Right? It goes on forever. It's infinite in size, right? So you can't actually write out every single one. So an important thing to understand here is that the numbers we're dealing with, they are real numbers. Now I don't say real as in, you know, like that they're real, which is kind of weird. But this is what they're classified as. We're talking about every single number in between all of those simple integers and whole numbers that we see. Everything in between. Real numbers are designated, if you want to talk about real numbers, we use this fancy R here. It looks like a capital R with a second vertical line attached to it. And this represents real numbers. So our domain and our range, right, everything we're dealing with here is in real numbers. This is important because we need to be able to classify things in between. Okay, so a good tip for this is when you're looking for the domain, you want to scan left to right with your pencil or your pen or whatever you're using and follow along on your graph and see where your pencil or pen is touching. And for the range, we want to go top to bottom. And we're going to do the same thing where we want to see what is your pen or pencil touching. Okay, so let's look over here, for example. And we're going to start over here. And note that we've got arrows on these, right? Which means that they are going to go on forever. But obviously we can't draw that because that would be infinitely long. And I don't have a big enough whiteboard for that. But we're going to say we start here. And I'm going to follow along this way. Follow along this way from left to right. And I see that my pencil or pen will touch here, and it will touch here, and it would go on forever in both directions, right? So when we write down the domain, and I'm just going to use a lowercase d here, I'm going to say that the domain is x equals all real numbers, okay? Could be any value from -infinity to positive infinity, anything in between. So if we look at the range though, well now we've got something a little bit different happening, right? So from the top, again, these are going off forever in those directions, so we could go to positive infinity, right? But then as we come down, we stop right here. So what we could say is that y is going to be greater than or equal to -2 for all real numbers, right? So the lowest possible number is going to be is -2, but then it could go on forever. So this is important to understand your inequalities here, in that you could have a greater than or a less than or greater than an equal to or less than an equal to symbol. And then this would basically say that the lowest number could be -2, and then it could go on forever, up to infinity. Okay. Now let's look at this one here. I've got a circle, okay, so I'm not going on forever anymore. And again, I'm going to take my pen here and I'm going to start from the left, and I see that I'm at -3, so again, I'm just going to write D and R. So I start at -3, And I go this way and I get to positive 3. And then it stops, right? And I'm including those points. So x is going to be greater than or equal to negative 3, or it's going to be less than or equal to positive 3, or anything in between. And same with the range. We're going to start from the top. We're at positive 3, and we go down and we get to negative 3. Now again, this shouldn't be too much of a surprise as it is a circle, so it should be equal everywhere. So our domain is from negative 3 to positive 3, and our range is from negative 3 to positive 3. And again, these are going to be for all real numbers. Because this continues, you get every single point in between on that line. We can't even make out every single point. If you could see them, then it would have been discrete. Okay, so that's domain and range for continuous functions, or continuous graphs.